Welcome back everyone. Today's PowerPoint is just review from foundations. Aluminum is the only subject covered in the P8 module for B level. Once again, PPE and all that comes with it. Since welding is an electric process, it is important to protect yourself from electric shock. Make sure workpieces and electric welding machines are properly grounded. If someone's getting electrocuted, shut off the supply. Or if you really like them, you can try to body check them. Your test is more concerned with proper gloves that are hole-free and dry. Safety protection and leather, which is usually first selection for welding. Leather protects against arc radiation. Cotton is usually the right choice for oxyacetylene cutting. Heated carbon dioxide breaks down into carbon monoxide, which over a long period of small exposure can cause heart conditions. Not good for you. Chlorine cleaning agents, also known as tetrachloroethylene, when heated breaks down into phosgene gas. Here's a quick summary. Here is our four main modes of metal transfer. For P8 gas metal arc welding solid wires, we will be most concerned with short circuit and spray transfer. The P9 module will cover globular. Short circuit transfer, also known as dip transfer. Wire makes contact with the work, short circuits, and pinches off. If you have too many amps, the wire will pinch off explosively, causing spatter. Direct current electrode positive is the polarity choice, and you can weld all positions. Short circuits used for carbon and only ferrous stainless steels are welded, and that's the 200 and 300 series stainless. When you turn your settings above the transition point, 27 volts and above, and you have at least 80% argon on a direct current electrode positive polarity, droplets of metal decrease in size and increase in speed to produce spray metal transfer. Because of the high heat and large weld puddle, you're limited to flat and horizontal. Another quick one here for you. On to power sources. Reminder, voltage pushes current through resistance. Electrical current is the flow of electrons moving in the wire. Another term used for voltage is electrical potential, which means it's the amount of work needed to move energy from one point to another. You'll see this term come up maybe on your red seal or on your upcoming P8 test. Voltage and potential are the exact same thing. The power supply for gas metal arc welding is constant voltage. Here's a look at the constant voltage voltamp curve, which is relatively flat. As amperage increases, there's a small drop in volts. The rate of voltage decrease is called slope and is measured over a 100 amp space. 2 volts is lost for every 100 amps of fluctuation. Slope is a relationship between volts and amps and how much current it takes to pinch off metal in a droplet form. This is most important for the short circuit transfer mode. Slope limits high points of current so that wire touches the workpiece. Current doesn't uprise too high, exploding the wire, resulting in too much spatter. Inductance increases the response time for touching and short circuiting the metal. Since spray transfer runs so high and does not make contact with the base metal, there is no need to trim the uprise of current. Together, slope decreases spatter and inductance improves arc stability. When using constant current for a power supply, which is widely used with suitcase welders, when you strike the arc, volts drop almost to zero. This is why the wire feeders are voltage sensing and responds to the dramatic changes in volts. Current level is adjusted by the wire feed speed. More notes. Filler wire designation, two governing bodies, the CSA and AWS. As you know, the main difference is the unit of tensile strength. CSA in megapascals and AWS in pounds per square inch. Solid wires can run all positions, so there's no position designator. Here's a breakdown. E electrode, R for rod, 70 is the tensile strength, in this case it's pounds per square inch. S indicates that the electrode is solid. And the last one is composition, in this case the 6. It has high silicon content. Next we'll look at a few variables. Wire feed speed is measured in inches per minute and is directly related to the current. Increasing wire feed speed increases current, deposition, and weld bead size because you're burning off more electrode faster. If you have a machine that controls wire feed speed by amperage, you can calculate to get the wire feed speed. The chart above shows for an 035 size electrode, you can multiply amperage by 1.6, and this will usually get you close to where you want to be for the wire feed speed. The 045 for wire feed speed is relatively close to the amperage. This flat constant voltage volt-amp curve shows small changes in volts and large changes in amps. When your tip to work distance changes, the amperage makes up the difference in the changes. Arc voltage stays close to where you set them. Too much volts breaks down the electrode and can cause lots of spatter. Not enough volts will not melt the wire efficiently and lead to a cold weld, usually with lack of fusion. Raising volts will flatten out the weld pool profile as well. In a constant voltage power source, when you increase volts, the arc length increases, flattens out. When you decrease volts, the arc length does the same thing and it decreases. For a constant current power source, it's opposite. Changes in arc length make big changes in volts. If you can remember from stick welding, closer to the work you have less volts and farther away you have more volts. This does not change for wire. This is why they have the voltage sensing suitcase welders to make up the changes. And travel speed, this is common sense, but I added it anyways. Weld bead becomes smaller overall with increases in travel speed. This is the last summary for the power review part. The next slide that I post will cover the aluminum welding, and that's the whole section in your P8 book.